Hello everybody. A very good afternoon to you all. I am Ganesan and I am really excited to share some parts of the 33 plus years of engineering experience that I have in retrofits projects in the hospitality sector. Retrofitting is becoming increasingly popular and it's even more critical now that the world is facing a global economic, health and environmental crisis. With the pandemic, global warming issues seems to have been put on hold to fight something more imminent. But in 2021, worldwide nations met again in the COP26 to find solution to this and understand how zero emission can be achieved in the next few decades. The hotel industry is a booming multi-billion dollar market. Technology has confined the market, so continuous innovation is necessary for hotel to stay relevant and competitive. Retrofitting, instead of building new, is the way to fight the current crisis that has strongly hit the hospitality industry. Today, I will take you on a tour of my 20 plus years of hospitality experience in energy efficiency project implemented across about 40 hotels in the Asia Pacific region. All right, let's get into the very first aspects of retrofitting energy efficiency. Let's look at power and lighting. I'm sure you all are familiar with single and three-phase power supply, which all hotels utilize. So, what energy efficiency measures can we implement on the power side? Let's focus on easy to implement, no to low cost measures to do the same. Energy monitoring and analysis. My first task wherever I take over any property is to check the commissioning of all equipment reports. In case these documents do not exist, then I start with recommissioning of plant and machinery to understand scope to start ECM and energy efficiency. Secondly, a clear understanding of the usage of energy for each area, that is, each piece of equipment is of supreme importance. Some of issues I have come across are listed here. If such issues exist in your hotel, they represent wonderful opportunity to undertake some retrofitting projects. The issues are listed here. Electrical loads not balanced properly, neutral wires carrying the currents, DV schedules not organized correctly, heat generated in ACB or MCCB, generally in outgoing load side cable, power factor not maintained, or issues in automatic power panel, tripping and failure issues, burned equipment or fused LEDs, high voltage during the peak hours followed by the low voltage, harmonic in fifth or seventh frequency level. Right. So, how can we correct such electrical distribution issues? Let's look at the first four issues. Electrical load can be balanced manually. When the load is balanced, your neutral potentially becomes zero and there is no leakage of current. When you balance the load, the DP schedule automatically gets addressed. This is a laborious process, but please understand that it needs to be done. There are no shortcuts here. Most of the overheating issues arise because of bimetallic contact. For instance, a brass washer used an aluminum cables to tighten the cable clamps. Wherever individual equipment draws unbalanced current, another issue is unbalanced load or voltage issues which needs to be corrected by preventive maintenance. Let's move on to other 5 to 8 issues one by one. Power factor corrections or automations need to be implemented by an expert, preferably an original equipment manufacturer. If this is possible, great. Else, retrofit it by comparing present power factor levels with desired levels. In my cases, ROI was reached within 1 year in most cases of 10 projects undertaken. In most cases, high or low voltage can be resolved by step changing in your transformer. I know that most of you are reluctant to open the transformer with the help of concerned experts, but the savings by doing so can be phenomenal. So please do it. In case problems still persist, look for an energy efficient stabilizers to control the voltage. This will resolve the voltage problems and address the other problem like equipment being burned, tripping issues, or LED fuse issues. Today, many advanced solutions are available to correct the power quality. Effective filters are available in the market. The first all important task is to have power quality analysis conducted. Based on the findings, reach out to the experts to implement customized solutions for your property. I have found the ROI for this to be about 2 years and benefit in terms of huge decrease in equipment failure cost and enhanced customer experience. EMS energy monitoring system enables the operation team to have complete control over the daily energy consumption across all equipment. I completed 4 energy monitoring projects by 2013. One of these was implemented in a hotel with 427 keys plus other facilities. This is a really helpful tool to measure the energy consumption before and after the energy efficiency project, thus enabling an accurate measures of ROI, maximum demand controller. It helps to monitor the power quality, reduced energy losses. Excess kVA can be returned to the electricity service provider. Reduction in demand cost, utility meter cross-check, power quality monitors. In order for your hotel to run efficiently and effectively, you need electricity. If you experience a dip or spike in power, your efficiency suffers and you run the risk of several other problems. In order to prevent the issues and allow your hotel to perform at its best, you need to implement power quality monitoring, which we call it PQM. The benefits are that it prevents interruptions, saves money, and increases associates productivity, increase the guest safety. Some of the images of thermographic audit, infrared scanning of electrical installations falls under the classification of preventive maintenance fault finding. The benefit is that we are now able to predict an electrical fault before the element fail completely. This image shows scanning of cable to check for overload or overheating or phase load imbalance. Here we are checking a circuit breaker for excess heat generated through the incoming and outgoing cable terminals due to issues like a loose connections or bimetallic issues or quality of workmanship. This is an interesting case which we handled in 2010. One water-cooled chiller was drawing up unbalanced current in different phases. Because of the excess heat generated, the compressor failed. When we finally conducted a thermographic test, we found that a bimetallic reactions caused this fault. Here, the bimetallic reaction was because an aluminum cable's clamp was provided with an EMS washer, which created this effect. Later, we corrected this during the shutdown. Saving from total utilization of power and light comprised only about 8% of energy, resulting in a monetary saving of 7 to 10%. A big chunk of saving comes from the HVAC, where power utilization is 50%, which result in a monetary saving of 20 to 30%. Let's move into strategies for demand control of HVAC, an area in which I have handled 40 plus projects. At the heart of the HVAC system is a chiller. Based on whether it is water cooled or air cooled, the energy efficiency measures will vary. When you undertake a retrofitting project, it makes sense to understand all the challenges of all equipment before you start. Only when you thoroughly understand the challenges, you can turn this into the opportunity for action. I have found that this approach helps facilitate retrofit project approval from the management team. Chillers do not load to the demand, thus necessitating the starting of parallel chiller to cater the demand. Condenser water delta T difference is not as required. Cooling tower delta T difference has not been achieved. Chiller water delta T is very high and not achieved. Set point even in ideal conditions. Heated fresh air is not automated. There is no scheduling of AHU, FCU and ventilation unit as BMS has not been commissioned or has not been completed due to gaps in coordinations and skills level of the execution team. There are no primary and secondary chilled water pumps or there is no zoning of pump, thus VFT not responding. Water flow is always constant. Ventilation requirement and basis are not known to the operation team, leading to maintenance issues and guest dissatisfaction. Heat recovery unit or adiabatic cooling is not installed for effective treatment of the fresh air. Free air cooled provisions not there. These are the example of challenges which I encounter in the many of the property. Let's move into strategies for demand control of HVAC, an area in which I have handled 40 plus projects. At the heart of the HVAC system is a chiller. Based on whether this is water cooled or air cooled, the energy efficiency measure will vary. We will address this one by one. HVAC equipment is more energy efficient when using a water cooled design versus air cooled design. There are several reasons for this, with the major factor being that the water temperatures are generally lower than the air temperature, thus reducing the system condensing temperature. In a refrigeration system, electrical energy used is greatly influenced by condensing temperature. It has been seen that integrated part load value, which we call it IPLV, of the water cooled system chiller can significantly lower energy consumption. In my experience, to tackle this HVAC high side, plant room side, integration must always be tuned to the CPM either through an upgradation of controller or sensor or through the Internet of Things, which we call it IoT. VFT for HVAC pump. This is a part of retrofit water-cooled chiller CPM project. Here, the primary, secondary chilled water pumps, condenser water pumps and cooling water fan together are equipped with the VFT, which are integrated with the CPM. You can see the saving as indicated on the slide. In case the hotel is equipped with the air-cooled chiller unit, we need to focus on a condenser inlet air treatment like a mesh system to provide a sustainable saving. Here, we are able to reduce the condenser air temperature instead of the condenser water temperature as in the water-cooled chiller unit. Cold outdoor air for cooling during the night and early morning. This is very simple measures utilize ambient air after filtrations and with controlled sequence into the air distribution system, thereby reducing the chilled water cold. In Qatar or Middle East, we can use this from the month of December to April. Passive cooling technique. Evaporative cooling. Evaporative cooling, as the name implies, provides cooling through the evaporation of the moisture in the air outside of the hotel. The cooling unit sucks the hot, humid air outside of the hotel into the unit through a large moist pad. When air is sucked through the pads, the evaporative process cools the air and a blower forces the now cool air into the required rooms. This process allows the hotel to provide a comfortable POH area without adding high energy costs. Sun, cool film and facade or atrium classes. This is one type of passive cooling, which is a building design approach that focuses on heat gain control and heat dissipation in a building in order to improve the indoor thermal comfort with low or no energy consumption. Awnings. This is another type of passive cooling technique which is very easy to implement and provides quick ROI if the space orientation facing in south, east or southwest. DFT, demand based for all kitchen exhaust. Demand control kitchen ventilation is a means of slowing down the exhaust fan and subsequent supply air in response to the actual cooking loads in a commercial kitchen. This project provided a very quick ROI, that is 9 months in my various project. Whereas in Middle East and like Qatar, within the 2 years, we can get the ROI in this project. Heat pumps. We decided to use the steam boiler only for the laundry and cooking purposes. For all other purposes, we used the hot water generated by the heat pumps through the ESCO models and provided an ROI in 18 months. Hope you all are familiar with the ESCO model. Or we can see in the some other video what is ESCO, how it is to be implemented in your property. Renewable energy. The world is changing to renewable energy and resourceful methods of handling waste. Just by looking at the travel industry, you can see how innovative some of the companies have come. It's necessary that this happens, and many businesses across world markets are realizing the rapidly increasing the market for renewable energy. Thank you for listening. You all have been wonderful audience. I do hope this presentation has inspired you to implement retrofit project at your workplace. Our duty to Mother Earth starts with energy conservation, energy efficiency and renewable energy projects. We hope that nature will continue to be generous and extend what we enjoy today to our next generation. Thank you.